Hey guys, it's Mike Mass. After recently acquiring one of these beautiful H145 helicopters from the folks at High Performance Group, I was so impressed with the machine and its capabilities, I decided to create this film to share my findings and some important tips with the sim community in an effort to help other pilots better understand the H145's forward flight and hover characteristics. I can truly say the H145 is at the cutting edge of helicopter simulation. Paired to Microsoft, you'll find it's unlike any other helicopter simulator. Congrats to the Hype Group for their amazing integration of both detail and performance. The minute the H145 loads, you'll immediately appreciate the countless hours spent to make this model mock every detail of its full-size counterpart. From the front seat, interior details are exact, right down to some aging. Complementing the H145 further is its amazing array of working navigation gear, allowing the pilot to create complex flight plans, complete with a selection of active maps and charts. If all that's not enough, the H145 can produce accurate ILS approaches to your favorite airports for times when there's reduced visibility. Aside from discussing the H145's features, I'll also dedicate a portion of this film to help both veteran and novice pilots to become more efficient in ground maneuvers, hovering, and landings. It's common knowledge helicopters require considerably more flight coordination and attention than fixed wing, for the simple reason that the collective and cycle controls 8 directions of flight. Making things more difficult is the fact every input made affects the track and stability of the other surfaces. For these reasons, flying helicopters can be challenging even for proficient fixed-wing pilots. In this film, I'll share a few techniques and maneuvers to help make hovering and landing the H145 a bit easier. I'll also share my thoughts and a few illustrations regarding some needed improvements to the 145's hovering parameters. Hopefully, the developers will consider implementing these changes to improve the H145's hovering and precision landings. Whether you're flying over the hills of Virginia or the crystal clear waters of the Florida Keys, there's definitely something special about helicopters with their ability to hover and land anywhere. For myself, it was this magic ability to hover which led me to a career in designing the first unmanned aerial helicopters almost 5 decades ago. Flying and navigating helicopters and drones with a video downlink and monitor has been around for decades. Back in the 70s, I designed the first aerial RC helicopters with a camera and video downlink to finally break the line-of-sight limitations with models. In 1977, I filed patent disclosures for an aerial platform called Helicam, a 12-foot rotor-span military and 35mm motion picture drone with multi-axis stabilization and a 2-camera downlink system. Here's some of the early 1980 images of Helicam during a contract with Martin Marietta Aerospace. Helicam used a forward-mounted camera for navigation and a second camera below for military target acquisition. Getting back to our H145, I can truly say this helicopter offers realistic forward flight handling. Hardcore maneuvering and cycling and tail rotor offer a predictable response close to that of a full-scale helicopter. Regardless of your style of simulator flying, be it transporting passengers airport to airport with the H145's impressive navigation and ILS capabilities, EMS or rescue, or just visiting landmarks in the U.S., the H145 is both challenging and fun. Having achieved the first inverted flight with a helicopter, I wanted to see what the H145 could achieve in aerobatics. While neither the simulator or the full-scale helicopter is designed for inverted maneuvering, I found by respecting rotor angle and airspeed, the H145 will do some nice aerobatics. To keep better tabs on my airspeed, I located my Logitech speed display center screen to produce an easy view of the speeds during aerobatics, approaches, and odd rotations. Just a few of the H145 aerobatics include a fairly nice axle roll, sustained inverted flight, a good-sized loop, or even this amazing inverted outside loop. The inverted outside loop requires a speed of at least 140 knots to achieve sufficient vertical height to complete the maneuver. Let's look at the H145's hovering capabilities. While even a novice pilot can hover the H145 well enough to taxi off a runway and land close to the gate, regretfully the 145's hovering characteristics are overly difficult, making routine ground maneuvers, hoverings, and landings difficult. To help pilot hover at more precision, the Hype Group implemented an automated hovering protocol. It's called GTCH, which locks the 145 in hover. You'll find this feature under the autopilot menu on the iPad. While hover automation works fine, it provides little help for pilots to learn the basics of hovering. For this reason, unless you're on a rescue mission, I recommend that pilots refrain from using the auto hover feature. In addition, you should occasionally turn off the 3 autopilots and the auto trim feature to get a better feel of what the helicopter's doing. It's a known fact flying a radio-controlled helicopter is considerably more difficult than full-size helicopters. I can testify to this since during my career I've taught thousands of professional military, airline, and helicopter pilots to fly our military drones as well as RC models. There are basically 2 reasons the H145 is challenging to hover. First, the flight parameters need correction, which we'll discuss later. And secondly, a sim model has reduced peripheral vision. Unlike a full-size helicopter where the pilot has a full view of his surroundings and skid height, flying a sim model, even with a 49-inch monitor, restricts the needed peripheral vision, making precision hovering and soft landings difficult. 1 second you're hovering, and the next you're sliding backwards. To help with visuals, as you approach a landing, zoom your view back to get the most surroundings possible. Since the skids are not visible from the seat to judge distance, your best bet is to look right through the rudder pedals at the ground. This provides the most accurate distance to the ground for your set down. To improve ground handling, when taxied to the hangar, try keeping the painted taxi lines directly on center. Follow the lines through the turns as well using cyclic and tail rotor. Getting back to the H145's hovering parameters, the reason the H145 is such a challenge to hover is because some of the control parameters are not correct. Having said that, it's important to note the H145 is still in a development phase and will only improve in the future. All helicopters, regardless of rotor head design or flapping, have a built-in stability factor called pendulum stability. This works to keep the disc and fuselage level. Therefore, after each momentary input, the disc automatically returns to somewhat level position. As a pilot adds a momentary collective input to the cyclic during hover, the rotor disc in helicopter tilts slightly. This upsets both the balance and weight of the fuselage in relation to the disc. Since the helicopter's weight is located far below the disc, once upset, it has a powerful authority to recenter its weight. This in turn relevels the disc again after the input. As it does, it neutralizes the pilot's last input. This pendulum stability and its ability to wash out momentary corrective input in hover is what is absent on the 145 model. For this reason, the H145 pilot is required to make multiple inputs. 1 input for correction, a second input back to neutral, then another pair of inputs to remove the original input to stop the helicopter from moving. This problem is easy to remedy. Rather than go through the calculations on the helicopter pendulum weight and moments and distances which have been upset by the input, the developer can simply incorporate a time element decay of the original corrective input. Therefore, after each correction, As the stick goes back to neutral, the processor begins a time element to cancel the input, allowing the disc and fuselage to level itself to mimic pendulum stability. Using this method will not affect the H145's forward flight abilities, since unlike corrective movements, which are momentary and in and out, forward flight uses a constant input which forces the disc and fuselage to remain in an offset position. Regardless, the H145 is presently a very capable model in both forward flight and hover. While precision hovering is challenging, the helicopter remains fun to fly. Another needed correction is ground effect. Generally, as a helicopter reaches about half the distance of its rotor diameter from the ground, the helicopter enters what is called ground effect. The reason this occurs is because the downward air pressure from the rotors cannot escape quickly enough, so the high pressure area tends to hold the helicopter in hover with less power. Ground effect also helps to slow and cushion the helicopter just prior to a landing. This can easily be remedied by the developers to ensure smoother, more realistic landings, which will help auto rotations as well. A great maneuver to sharpen helicopter skills is engine off auto rotations. I found the H145 auto rotation parameters somewhat relaxed to allow new pilots to pull off successful auto rotations. I noted after an auto rotation, I can actually lift back and hover again. When performing auto rotations, make sure to select the H145's realistic mode on the iPad. An ideal height for autos is around 1,000 to 2,000 feet. While maintaining level flight at 75 to 100 knots with the runway out in front of the machine, pull the throttle on the collective down and shut off both engines. Keeping the collective at full low position, gently push the nose down enough to maintain a minimum of 50 to 75 knots as you approach the landing area. When the helicopter reaches 100 to 200 feet, pull the cyclic back slowly to raise the nose. This will both slow the airspeed down for the landing and increase the rotor RPM. When the forward speed reaches 10 to 20 knots, add collective pitch to further reduce the speed and land the helicopter. Here's a downwind 180-degree turn auto rotation. While a left-hand turn is somewhat more difficult since we're turning into the retreating blade, it allows for a much tighter turn to get back upwind again for the landing. All in all, I've had a blast with the H145 since the day I installed it. Paired to Microsoft with its amazing landscapes and graphics, it's a game changer. Microsoft's recent USA upgrade adds countless locations you can fly to, land, and admire the scenery. In conclusion, congratulations to the Hype Development Group and of course Microsoft for offering such a great simulator world. Be safe and thanks for watching.